Hello everyone. Welcome back to the AWS Certified Solution Architect Associate Certification Bootcamp. In this video, we'll focus on two crucial concepts in cloud architecture: high availability and scalability. These are foundational principles for building reliable and resilient systems in AWS. We'll also understand how EC2 supports this through scaling techniques and load balancers. We'll start with what is high availability. High availability means designing systems to be continuously operational and accessible with minimal downtime, even in the event of failures like server crashes, hardware faults, or availability zone outages. In AWS, this often involves deploying your application across multiple availability zones. Let's assume you have a web application running on an EC2 instance in one of the availability zone, which is UST 1A. If that availability zone goes down, your application becomes unavailable. That means it's not highly available. To achieve high availability on AWS, you run your application on multiple EC2 instances across availability zones, at least two availability zones. If one instance or availability zone fails, the traffic is automatically routed to the healthy instance in another availability zone. And as a result, your users don't experience downtime and your application remain up and running. That's high availability. This design minimizes single points of failure and helps meet SLAs. Let's review scalability. Scalability is the ability of system to handle increasing workloads by adding resources. Let's assume your application has steady state load of 10 requests per second and suddenly there is a traffic spike and your application started receiving 100 requests per second. Without scalability, your application will be slow and user will see latency. How you can handle that? You can increase the power of a single instance. That means you can add more CPU and RAM. As an example, if your existing EC2 instance was T3 small with 2 vCPU and 2 GB RAM, you can move from T3 small to a bigger instance like M5 2x large, which will come with 8 vCPU and 32 GB of RAM. That means you are adding more power to your EC2 instance to handle the additional load, or you can add more instances to handle that load. When you are adding more instances, you are not increasing the instance size or the RAM or CPU, rather than you are adding the same node or the same EC2 instance more than one to handle that load. The strategy in the left hand side is called vertical scaling, where you are adding more power. Vertical scaling is useful for applications that cannot be split into smaller pieces, or if it's a monolithic application, or the application components are tightly coupled. However, the right hand side approach is called horizontal scaling, and horizontal scaling is ideal for applications which are stateless like web servers. For the AWS certification, it's important to understand the difference between vertical scaling and horizontal scaling, because mostly you won't see this terminology. Rather, AWS will use scale up or down to represent vertical scaling. Vertical scaling means increasing the power of a single server. For example, upgrading from T3 small to a M5 2x large. It's simple and effective for quick improvements, but it has limitations because you can add only a limited number of CPU or RAM or hardware in your EC2 instance, and often vertical scaling requires a brief downtime. That is why it's good for legacy apps or monolithic systems that can't scale horizontally. On the other hand, you can see the terminology like scale out or in to represent horizontal scaling. Horizontal scaling involves adding more EC2 instances to handle the increased traffic. This is highly effective in cloud environments because you can scale in and out without downtime. It works best for stateless applications where each instances can process requests independently. Horizontal scaling lays the foundation for high availability, especially when combined with load balancing. Before explaining high availability and scalability in the context of EC2, we must understand two more concepts. The first called autoscaling group or ASG and the second load balancing. Let's start with autoscaling group. An autoscaling group is an AWS service that automatically adds or removes EC2 instances based on traffic or performance metrics. Let's assume you run your website on EC2 and during regular hours, you only need two EC2 instances to handle the traffic. But during a sale or during an event launch, traffic spikes suddenly. An autoscaling group will add more EC2 instances to handle the additional load. You got some more traffic, one more EC2 instance. Some more traffic, autoscaling will automatically add one more EC2 instance. And after the rush, when traffic drops, autoscaling group removes extra instances and it will go back to your regular or the average EC2 instance count, which is 2 for our case. And as a result, you handle the peak traffic burst without manual intervention and you will pay only for what you use. Autoscaling group also ensures that instances are replaced automatically if they become unhealthy. Let's assume out of the two EC2 instances, one instance is unhealthy and not responding. Autoscaling group will automatically add one more new instance. It also ensures the system scale out during high demand and scale in during the low traffic period, and you will always have the right number of EC2 instances running for your application. With the help of autoscaling group, you can control the EC2 instance count based on the application load. But if you are thinking how a web application with varying number of servers will receive the traffic, are you going to use elastic IP or static IP for this? The answer is no. Load balancer resolves this issue. A load balancer acts like a traffic cop that routes requests to multiple backend instances, which ensures one single instance does not get overloaded and it does not create a bottleneck. It also improves both performance and availability. Currently, AWS offers 4 different types of load balancers. To start with, application load balancer, which is for HTTP and HTTPS traffic, network load balancer for ultra low latency TCP traffic, gateway load balancer for network appliances like firewalls, and classic load balancer, which is a legacy load balancer, and AWS does not recommend you to use classic load balancers. Using load balancers, you not only distribute traffic but also enables zero downtime deployments like blue-green or rolling updates. It helps to maintain consistent performance under variable load. And load balancer also perform health check and route traffic only to healthy instances. You can combine auto scaling and Route 53 for DNS level control, and you can eliminate the requirement of static IP or elastic IP, and it will be central to any high available architecture. Now let's understand an example of highly available architecture in the next slide. To make your architecture with EC2 instances highly available and scalable, you use auto-scaling group deployed across multiple availability zones. You distribute your EC2 instances across availability zones for high availability. You use Elastic Load Balancer or ELB to distribute traffic between the EC2 instances. You can combine health checks with your Elastic Load Balancer to replace unhealthy instances. You can also monitor and adjust capacity dynamically. And for monitoring, you can use CloudWatch metrics to trigger the auto scaling or scale out and scale in based on the application load. Before we wrap up, please remember high availability ensures uptime, which minimizes downtime. Scalability ensures performance, that means handle more users or application load, Vertical scaling power-ups a single instance with more CPU or RAM and we call it as scale up or down, whereas horizontal scaling distribute the load across many EC2 instances and we called as scale out or scale in. Load balancers plays a vital role in distributing traffic and improving resiliency. During the certification exam, you can expect scenario-based questions which will ask you to choose between vertical or horizontal scaling or how to improve availability using load balancers and auto scaling. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.